The basic structure of the machine is on almost every machine the same. We got a polymer concrete table with a big enclosure around, and we have the gantry, like a big portal that goes over the table. So it has two drives in the y-axis, and this gantry portal holds the x-axis and the z-axis with the spindle. The only exception for this is the Datron Neo. On the Neo, we have a table that moves in Y. So we got a stiff x-axis with the mounted z-axis and spindle, but the table, in this case an aluminum plate table, moves in the Y direction. We got 500 by 400 millimeters of working area on the Neo. It's the smallest machine that we have, other than the ML that we just saw, which has 1500 by 1000 millimeters. The MX Cube is like the strongest of all models. It has an 8 kilowatt spindle. It comes with an HSK E32 collet, so very stiff holders, up to 34,000 RPM. And like, I would say the standard machine, the M8 Cube has 1000 by 700 to, in terms of the working area. What I want to stress out here is the footprint of the machine. We have a footprint of around 5 square meters on this machine. And we have, like I said, 1000 by 700 of working area, of machinable area, which gives us like a ratio, like a factor of 1 to 7. So for 1 square meter of machining area, we need like 7 square meters of footprint. If you compare this factor to big machining centers, to vertical machining centers, this factor goes up to like 1 to 15, 1 to 20. So in conclusion, you need a lot more floor space for just one spindle and one machine. So that saves you a lot of costs on the on floor space side. When we take a look at the table of the M8 Cube, we can see all these little cones, these inserts in the table. So what we have is a zero clamping system integrated in the machine table, so we can just mount any clamping device that we want to use on the machine, bolt it down, and it's perfectly aligned to the gantry and to the machine system. In this case, we have a breakout table on the M8 here. We got a vertical clamping system. You can also use it for a fourth and fifth axis as an option. What this flexibility means on an ML Cube and how we can make most out of it, let's take a look at the ML now. Now on this ML Cube, we have a large setup of different clamping devices and solutions. On the left third, I'm using a vacuum table which has 1000 by 500 millimeters. Beside, I got my mechanical vise, just a standard vise that I can clamp with a standard wrench. In the back, a special vacuum jig, a special vacuum mold, basically. So it's the negative form of this entire pocket. So I don't have any like straight or square edges where I can clamp it. So we need to design special fixture which goes with vacuum. So we got vacuum connection straight through the table. We got T-slot tables in different variations. This one is basically a plain one, so you can add small little clamps, or you use your own clamping solutions or end stops for this. It's very flexible, and also the short stroke elements. So this works with compressed air. I can move this element wherever my part will be located. Put it in place, release this horizontal stroke, and the part is clamped properly. You can see we still have some space left on the table, so we can add more devices, more vices or any other clamping solutions. So in the case that you have, let's say, a part with different operations, so let's say you want to separate the parts from a big sheet of aluminum on the vacuum and then have to do a second or even a third operation, you can just do this side by side. So you don't have to take off your clamping devices each and every time. And what we just saw on the M8, we do have the option to get this ML cube table with a cutout in the front, so we can clamp parts vertically. If you have like big parts that have like side holes or any threads, that would work as well.